This is Unit 8, Area and Solids. Lesson 8.3, Arc Length and Sector Area. Make sure you get the date, time, location, as well as a parent or guardian sign-off. Students, do not attempt to multitask. Focus the next few minutes exclusively on this lesson and your retention will increase. You're going to work on this page by yourself. At some point, you're going to need a calculator. Solve for the unknowns. Pause the video, then restart. Welcome back. Let's see how you did. I'd rather you have tried these and got them wrong than leave them blank and just copy it down. That's not as much of a learning experience. These are regular polygons, which means the area equals perimeter times apothem over 2. So you walk the perimeter around 1, 2, 3, 4, 5, 6, 7, 8, 9. Our perimeter is going to be 9 times 16 times the apothem, which is 22, over 2. So here we have 9 times 16 times 22 divided by 2. You should have gotten 1584. 1584 there. 1584. Check for units. No units. You go unit squared. There is your area. Some of you forgot to physically trace around and you didn't get that 9. So if you got that wrong, make sure you physically trace that around. This one again, perimeter times apothem over 2. Our perimeter, walk it around. This one we have, it's going to be 8 times 3, 24. Our apothem is 4 root 3 over 3 over 2. Now, that might bother you a bit unless you simplify. This 3 can go into the 24 8 times. I'm going to take the 2 into the 4 twice. And my area is going to be 16 root 3 units squared. Area of a regular pentagon has an apothem of 8 meters and an area of 232 meters squared. Find a single length size. So area equals perimeter times apothem over 2. Circle plug chalk. My area is right there. 232 equals perimeter, which we don't know here, but I do have my apothem, which is 8 over 2. Cross multiply. So to get my perimeter, it's going to be basically 232 times 2 over 8. And we got 58. And that equals our perimeter. To get a single side length, it is a pentagon. We're going to divide by 5. Need to be okay with decimals here. That's perfectly fine. And our side length, therefore, is 11.6. If you stopped at 58, it's because you didn't read the question. So last class was about regular polygons. This class, we're going to go back to circles. We're going to talk about something called arc length and sector area. Keywords: circle area, circumference, arc length, sector area, central angle, and of course, theta. I want you to imagine that you have a orange slice in front of you. So that's an orange slice. And the radius of the orange slice is 10 centimeters. It's very large, actually. 10 centimeters physically is large for a radius of an orange. Maybe I'll change that to grapefruit next year. 10 centimeters. And what I want you to do is we're going to find both the circumference and the area of this orange. Always physically trace your diameter. Do not let your eyeballs pick that up. Now, what we have found is if we were to call the circumference would be the length of this orange peel. Keep that in mind. If I were to flatten this peel out, okay, if I could slice that peel and flatten it out, the length of the circumference is that distance around. Trace it around. A little arrow there, so I can unfold that. Theoretically, I could slice that peel off and flatten. That's the length of the circumference. That's going to be, imagine, the peel of the slice. The area of the slice, of course, would be the actual orange itself, or the pulp. Peel and pulp. What we're going to be learning is, what if I only wanted a length of the peel, a small section, like the length of that small section of peel, or the area of this wedge. If I wanted the actual length here, we call that arc length. Now, that is not the same thing as arc measure. Arc length and arc measure are not the same thing. Length would be this actual peel that I could flatten and I could find the length of. Arc measure would be like the degree curvature. So arc length is not the same thing as arc measure. If I wanted the area of a wedge, that's called a sector area. Sector area. So how do we find arc length and sector area? These look like really complicated equations, but they're not. So if you watch very, very carefully, they're not complicated. To find the length of an arc, if I wanted to find the length of that arc, it is simply a an arc length is simply a fraction of the circle's circumference. What is a fraction? A fraction is a part of something over a whole. of something. A part of something over a whole of something. Box that word fraction. Draw a little arrow. Fraction means a part of something out of a whole. So it's a fraction of, that means multiply, the circumference. We're just going to put a giant C there, meaning circumference. So arc length is a fraction of circumference. Now, what fraction do we use here? We use a central angle theta. So the part is going to be angle theta over the whole. Sweep this circle around, all the way around. Sweep it around. That's where the 360 comes in. That's part over whole times circumference, which is d pi. Now this fancy equation, all this translates to is center. Yes, I want you to copy that down. Arc length is a fraction of the circumference. Arc length is, that's that equal sign, a fraction, that's that right there, of the circumference. That's that right there. Arc length is a fraction of the circumference. Now, sector area. Again, that's like the orange slice. Let's go ahead and shade that. A sector area is a fraction of a circle's area. What is a fraction? It's a part over a whole times the circle's area. Fraction of, that's times. What does this look like as an equation? Well, the part, once again, is going to be that central angle theta. Sweep the whole, which is 360, times area, which is pi r squared. Sector area is a fraction of the area. A fraction of the area. Let's put these two equations to work. So in the circle below, the degree measure, we're going to find the degree measure of the arc AC, and then find that length of the arc AC in exact form. The radius is 10 centimeters. Step number one, let's trace our arc A to C. The measure of the arc. When we see the word measure, think degrees. Measure of a central angle to its arc the same. So the measure of the arc is 45 degrees. A little m, AC equals 45. Measure of a central angle to its arc the same. Measure means degrees. Now, if I actually were to slice this peel here and flatten it, and I wanted to find its length, arc length is a fraction of the circumference. Circumference is d pi. The way I do fraction, that's theta over 360 times d pi. If I wanted to find the length of AC, my theta is 45 over 360. My radius is 10, which would mean my diameter is 20. And then pi. Challenge yourself. It's an exact radical form. Challenge yourself to do this as much as possible without a calculator. Okay, let me show you some of the tricks to do that. See the zeros? If I have a zero in the numerator and the denominator, you can simply pretend they're not there. 2. I'm going to take that 2 and go into 36 to reduce it. So 2 goes into 36 18 times. Go ahead and circle 18 and 45. 9 goes into both of those. 9 goes in here 5 times. 9 goes in there twice. My final version of everything, and this is called exact radical form, exact terms. Arc length, AC, equals 5 halves pi, check for units, I think it's centimeters, yes, centimeters. So my arc measure is 40 degrees. My arc length is 5 halves pi, or 5 pi over 2, same thing. Let's try sector area. We're going to find the sector area ABC. So let's just kind of shade that. Sector area is a fraction of the area, and area, of course, is pi r squared. So to find that sector area, that's theta over 360 times pi r squared. Circle plug chug. My theta is going to be 45. 45 over 360. My radius is 10, so watch what I do. I'm going to go 10 times 10, and then I have pi. Let's zoom in. Again, challenge yourself to do this without a calculator. You really, really can. I'm going to take 10 and go into 360, and I'm going to reduce it to 36. 45 and 36, 9 goes into both. 9 goes in here 5 times. 9 goes in there 4 times. I'm going to circle the 10 and the 4. 2 goes in there twice. 2 goes in there 5 times. There's nothing else to reduce. So my sector ABC equals 25 over 2 pi. Now it's centimeters squared because it's area. I suggest you pause here just for a moment. In fact, I'm going to set the timer for 30 seconds. And in those 30 seconds, in your mind, I'd like you to re-explain to yourself what on earth is the difference between these two pages, between arc length and then sector area. What is the difference? Take about 30 seconds, re-explain it to yourself. Go. All righty, let's try. We're going to do this page together, and you'll do one page on your own, folks. Okay, in circle Q, the radius is 9 yards. We're going to find the arc length of the major arc, EGF, and the sector area, EGF, in exact form. First off, I'd like you to trace EGF, the arc. Let's find the degree measure. We already have it. Now we're going to find the arc length. Arc length is a fraction of the circumference. Sector area is a fraction of the area. So let's plug in what we can. 285 is going to go right there for both. There's your theta. Our diameter is 18. That goes there. R squared goes right there. We're going to bring this in close for both of them. We have 285 over 360. Our diameter is 20, then pi. Over here, 285, 360. Our radius is going to be 9 times 9. Excuse me, that's not 20 there. That's 18. Excuse me. I'm thinking of the last one. 18. 9 times 9 is the radius squared, pi. Notice I didn't multiply it out because the key to multiplying is not multiplying. It's factoring. Okay, once again, we're going to challenge ourselves to do as much of this without a calculator as we can. I'm going to start by taking 9 into both the 18 and the 360 because I know that's easy to do. 9 goes in here twice. 9 goes in there 40. Now I'm going to reduce a little bit more. Obviously, 5 will go into the top one. So 5 goes into 40 8 times. I'm going to come up here and do this one longhand. So 5 goes into 285. $57 times. Now you ask yourself, is there anything else you can reduce? And there is. See that 2 and the 8? That reduces. Look at what you're left with, folks. You're left with 57 over 4, and there's nothing else you can do. So my arc length of EGF, the length of the arc, is going to be 57 fourth pi. I think our units was yards. Yes. Yards. That's your arc length, fraction of circumference. Let's come over here. See how we can reduce. You just kind of keep hacking away at it. I know 9 goes into 360 40 times. Once again, I'm going to go ahead and reduce the 40 and the 285. 285 divided by 5. 5 goes in there 57 times. 5 goes in there 8 times. I see if I can reduce any other way. I can. So last but not least, we multiply. Longhand. Hang tight. Something's wrong here, folks. Let's try this again. 9 times 57. Ryan's fried at the end of the day. I'm going to times by 9. That's 9 times 7 is 63. So that's 3. Carry the 6. 9 times 5 is 45. That's 500. And yes, it is 513. So we finish up here. It is 513 over 8 pi yards squared. And that's your sector area. This page you're going to do on your own, folks. Again, do this in exact terms, no decimals. I made the math a little bit easier than mine. Go ahead, do this on your own. Pause. Do not cheat. Pause. Do this on your own. Welcome back. All righty, so here, first I want the degree measure in bold, degree measure, and that is simply 210 degrees. The arc length is going to be the fraction of circumference, which is 18 pi. Should have reduced this as far as you can. Watch carefully. I can kill the zeros. All right, I'm going to see 9 goes in there twice. 9 goes in there 4 times. That's also 1 and 2. And my final answer is going to be 21 over 2 pi, check units, kilometers. This one down here. Find the measure of the bold arc. That's an easy one. It's 90 degrees. Arc length, fraction of circumference. We trace it. D pi. And just reduce the daylights out of this. And your arc length, you should have gotten here 5 pi, check units, feet. Highly recommend you set your timer. The 2 minutes on your phone and flip through each page and just verbally rehearsed what you learned. By taking this mere 2 minutes, it will greatly enhance your retention even weeks down the road, especially when you're facing something called a final. Take the time to do that 2-minute recap.